I'm Jasmine Moertle Litson, and I did a flood risk assessment of the greater St. George area based on land cover, land use, and watersheds. There we go. My study area is the greater St. George area, which is located in southwestern Utah in Washington County. It is approximately about 10 miles from the Arizona border, so pretty dang close. The climate of the area is really similar to Tucson, where it's hot in the summers and cool in the winters, but very little precipitation. But when it does rain, it tends to flood. In the past, most of the flooding has stayed along the major rivers, which were the Santa Clara River, which is the blue line that you can see coming down close to Santa Clara, and the Virgin River, which cuts down a little bit south of the map here. And but since then, we've had flooding that's actually occurred within the cities, particularly in 2018. There was a large flood that occurred in the Washington area, which is right over here on the map, and caused tons of damage in the area. And I wanted to determine if this was due to development in the area or if things had just kind of naturally changed to cause those floods. The data came from two different sources. My first data came from the USGS Earth Explorer. I collected data from 2008 and 2018 to determine the land cover land use analysis. After that, I collected data from the Utah Geospatial Resource Center. And with this, I collected my DEM data for my watershed analysis, census data so I could see who this flooding is actually affecting, and other vector data for the reference map. I used two methods for my land cover land use. I did supervised and unsupervised. With the unsupervised, I did the ISO cluster tool, then reclassified that data into 5 particular classes. Those 5 classes are developed, forest, desert vegetation, bare ground, and grass and agriculture. St. George and the surrounding cities are located in a desert area, so that's the reason for the desert vegetation and bare ground. Obviously developed because I wanted to see how much the area has developed over time. And then there are some forests to the north and small forested areas within the city, and there were large grass and agriculture areas to the southeast of the city that I wanted to see how they changed over time. The supervised data, I chose the 5 training samples similar to, those are the same as the classes that I just discussed. On the map, you can see some of the training samples throughout it, and I'll tell you what those different colors mean in just a minute. Then I ran the SVM tool and classify raster tool. The SVM tool is actually found to be more accurate than doing the maximum likelihood, which is why I chose that particular tool. And from there, I'll show you my error matrices in a minute, but just to point out a few things on the map, you can see this light green color in the southeast corner. That is grass and agriculture. The purple colors that you see throughout the maps, those are developed areas. This light gray is bare ground. This yellow orangey color is desert vegetation. And then there's some light green that you can't see too particularly well. But they're in these really dark areas, and they're the forested areas. For the watershed analysis, I created a hydrologically conditioned DEM, and then I created a flow delineation showing the streams and where they went to, which then I used to create the watersheds themselves. On the Utah Geospatial Resource website, I found a floodplain mapping that they had as a vector data. And what I did is I reclassified these based off of the information that they gave into the different kinds of flooding. The darker or the more red the color, the higher the risk of flood compared to the lighter colors. And these big yellow areas are where those 2 rivers flow through. So the Santa Clara rivers on the eastern side, and on the western side is the Virgin River. And those big yellow areas are the base floodplains for the area. I used this data and I overlaid it on the land cover land use maps, the watershed maps, to kind of show how they correlated to each other. For census mapping, like I said, I wanted to see what population was widely affected by this flooding. So I did a minority population where I took the minorities divided by the total population times 100 and plotted that out, or mapped that out. And then I did an income where I separated it into 5 variables. I manually separated it. When I did different separations, it didn't separate it quite the way that I wanted it to show. I wanted to really show those low incomes versus middle versus high income areas. And because there are so many low income versus so many high income, it was hard to separate them out to see where that middle class would be. So I separated it out this way instead. This is my results for my unsupervised data from 2008. You can see that it's pretty largely developed, and it's spread through the middle of the map. Those light green and dark green areas are those grass and agriculture and forested areas. In the southeast corner of the map, you can see that there is a large area that's grass and agriculture. Those are actually some pretty large farms for the area. Surrounding the city, you see a lot of desert vegetation and some bare ground, which are those lighter and darker cream colors. Unsupervised data shows basically the same thing, where you have those separate classes. The forested areas tend to take over where those grass and agriculture areas are throughout the city. Those are a lot of parks in the city, so they have both grass and forest. And so they kind of interchange between the supervised and unsupervised data. You can see those large farmlands in the southeast corner of the map again, and you have the large amounts of desert vegetation surrounding the city. I did random sampling and equal interval sampling error matrix for all of my data to see how accurate my data actually was. The overall accuracies were between 70 and 84%, with the kappa score of 0.59 to 0.76%. So fairly accurate. Most of the issues came from the developed areas. And those developed areas, when I looked back at the Landsat data, had very similar looks to them as the surrounding area did. So they typically got mixed up, and you'll see that this is true even in the 2018 error matrices. So for 2018, we have a lot more developed area, a lot more of that purple developed color. And we have more forests. We had a little bit of decrease in the farmland, especially in that southeast corner. That farmland has now been developed mostly. Yeah. And then in 2018, again, you see that large amount of development that's spread across the map. You see a little bit more grass and agriculture, but it's that same concept where it's being interchanged with those forested areas. Again, you see in that southwest corner that that area has been developed, and those farmlands have shrunk down. Something else is they don't have as much of the desert vegetation in the area. It's more of the bare ground. And this is related to a drought that we had through that particular time. Again, my overall accuracy was 70 to 76%, and the kappa values were 0.62 to 0.67. So again, fairly accurate. Most of my issues were through that developed area. Again, because of the fact that it gets misrepresented. And one thing I noticed is that the grass and agriculture and the unsupervised data had a little bit more of an error in this one as well. And that was because it played off of that forested area. The Watersheds analysis produced 4 main watersheds for the area. These are fed by melting snow from the mountains to the north and the east of the area. They are just over 500,000 acres in size. and it's fed by the two main rivers in the area. So the lower Santa Clara River watershed is fed by the Santa Clara River. The other river, the Virgin River, is what feeds the bottom three watersheds. My census data showed that there was a higher income, so the darker colors, in the western part of St. George, and the eastern part of St. George had a lower income overall. I overlaid the floodplains just to kind of show where those natural river passages went. And you can see that there are smaller floodplains in the western part where the wealthier communities are, and where the poorer communities are, they have more of those. They have a bunch of small ones, but they also have the larger Virgin River floodplain that intersects them. The percent minorities, again, we see the same kind of concept. The lower minorities are in the western section of the map, and the eastern section of the map have higher minorities. So again, you have their higher income, low minorities with the small floodplains, and the low income, high minorities with the larger floodplains. So that means that they have a likelihood of a higher chance of flooding in their area. So I ask 4 main questions of this project. The first one is, how has land changed between 2008 and 2018 in the area? And we can see that there's more developed land. There's about 2,000 acres more developed land. There's a lower amount of desert vegetation that increased by over 2,500. So there was that drought between those time frames that really cut it off, plus the development cut some of that off as well. There's a decrease in grass and agriculture. This is less than 100 acres, but it's still visible in the area. And there's an increase to forested area due to those parks being built. What areas are prone to flooding in the greater St. George area and why? Well, obviously along the rivers, because you have those base floodplains. If those rivers flood in, they're going to have more flooding surrounding them. The southern section along the Virgin River, so down here in southern St. George, there's the spot where the Virgin River and the Santa Clara River meet, and that area is very prone to flooding. And this actually intersects a lot of developed area, which means that those areas are more prone to flooding now as well. Is there a correlation between the greater amount of development and the likelihood that certain areas will be affected by flooding within the area? Why or why not? In 2008, you can see that the floodplains are not widely developed. They have some development surrounding them, but not a whole lot. And in the city, that was enough to make those natural drainage passages down to the south to clear the rivers and stuff like that out of the main part of the city. In 2018, you see that these areas have been pretty widely developed. You have a lot more of that purple color along the area. And due to this, you have more chances of that area being flooded. Particularly in 2018, there was a flood that occurred in Washington City, and there is a small branch of a natural floodplain that runs through there, and that area was developed on the natural floodplain, so the water had to find another route, which wound up going into people's homes in Washington. The land use and flood zones show that their area being developed in the area also occur on these natural floodplains, so they have to find another way to drain it out, and if they don't, water backs up into the poorer communities. As shown on this map. So in the percent minority map, you have mostly high minority communities and more minorities that would be at risk for dealing with flood issues. So in this northeastern portion of the map, you have those higher percentage minorities, and that's a lot of where they've built up on top of the floodplains. So the flooding has nowhere else to go but into people's homes. And in the lower income communities, they were built along the areas where more flooding has occurred, so development has occurred there. And these areas are normally a 0.2% to 1% likelihood that they'll get an annual flood, but now these areas have increased the percentage of chances of getting a flood because the natural floodplains have been blocked. In conclusion, minorities and low-income communities are at higher risk of being flooded because of the area being built up. In 2008, there would have been area where the water could have drained naturally through floodplains, and the greater St. George area is being developed quickly. The builders aren't considering the natural water passages and floodplains in the area, and this can cause extreme flooding as it did in Washington in 2018. There is an overall increased risk of flood and a large flood in the area. So the cities and developers for the area need to examine the watersheds, floodplains, and floodplains in the area to determine if there's a better way to mitigate flood risks. Thank you.